Hello everyone, I am Saptarshi Mukherjee. I am a software engineer 3 at Google and I've been a computer programmer for some time. In this playlist, we are going to discuss, we are basically in the process of discussing the different problems of Codeforces around 923, how we can solve them using different approaches, etc. And in this particular video, I'm going to focus on this problem, Klever permutation, problem E. So yeah, let's get started. If you like the videos, do consider liking, sharing, subscribing. Please share with folks who might find it interesting. So okay, let's see what the question is about. We have n and k. We have to construct a k level permutation of length n. So there's a constructive kind of problem. You have to use some constructive algorithm. A permutation is called k level if among all the sums of continuous segments of length k, any two sums differ by no more than 1. So any sum of contiguous segments of length k basically means this. So you're taking k continuous elements and their sum is basically Si. What is I? I basically is the first element of that subarray. Now all these SIs, if you take any two SIs, the difference will be maximum 1, less than equal to 1. So a permutation is called k-level if max of S minus min of S is less than equal to 1. Max of S minus min of S. Okay, that means the absolute difference between any two of them will be 1. Maximum 1, either 0 or 1. Now we have to find any k-level permutation of length n. N can go up to 10 to the power 2 into 10 to the power 5. So we have to think in terms of linear or some constant times linear, maybe n log n at the maximum. We can't go up to n square. That part is clear. Now the test cases, if you look at this 2, 2, the answer is 2, 1. How? If you look at 2, 1, n equal to 2, we can see that k equals to 2. K equals to 2 means subarrays of length 2. There is only one subarray of length 2. So it doesn't matter. Whichever way you keep it, 1, 2, 2, 1, it's the same. 3, 2. For 3, 2, you have 3 blanks. Let us see the answer. The answer is 1, 3, 2, the output, given output. 1, 3, 2. Now how many subarrays are there? Of length 2, k is equal to 2. So here k is equal to 2. So let us see, you have this one and you have this one. Here the sum is equal to 4. Here the sum is equal to 5. So yeah, this is correct. You could have also done it differently. You could have said, hey, I want 2, 3, 1. Here also the same thing. Sum here is 5, sum here is 4. So the difference is 1. Let's see if you could have done it differently. 3 on one extreme. So 3, 1, 2. Then basically the sum here is 4 and the sum here is 3. This is also correct. Similarly 2, 1, 3. If you try 3, 2, 1, then probably it will not happen. So these are some valid examples. You can have many possible outputs. You have to print any. I think that is given in the question. That output any k-level permutation. Any is highlighted. Okay, so now how to create the strategy for these problems. One strategy is look at the given test cases, look at the outputs, and then try to figure out, hey, for any case, how the output is getting constructed. Try to hack the kind of strategy that has been used by the person who has written the outputs of the test cases. But if you have to approach it mathematically, then how can we do it? Let's say you have some n places and you have some k, which can be anything. Let's say k is 4, this k. Now this has to be equal to this one. Not equal, it can be equal or plus 1 or minus 1. Now between this pink one and this purple one, what is common? These elements are common. The pink one additionally has this element, the purple one additionally has this element. Now the question is, that means this pink one basically is some common sum plus some constant plus the first element, that is a0. And the purple one basically is the same constant plus this one, which is a of 1 2 3 4. This is a of 4, which means if the difference between these two is going to be plus minus 1 or 0, that means the difference between these two elements is going to be plus minus 1 or 0. So basically, if I say that this element is x, then can I say that the difference between this and this element has to be maximum 1? Can this element be x? No. There's a permutation. Permutation basically means that from 1 to n each element will occur exactly once. So you can't have the same element occurring twice. So this cannot be x. What else can it be? It can be x plus 1 or x minus 1. Right? So we can take either of them for the time being without loss of generality. We can say that, hey, let's take it x plus 1. Does that solve my problem? I have to figure out the remaining as well. So, okay, if this is x, then I need to manage x plus 1 over here. Fine. What about the next one? For the next one, can I say the same thing? The k is same. Over here, I have taken k equal to 4. So now for the next one, can I say, okay, this is one subarray and this is another subarray. Between these two subarrays also the difference will be maximum 1. So which two elements am I going to focus at? This element and this element. Between these two elements, what can I say? Again, these are common elements. These three are common elements for those two subarrays I have marked. Which two subarrays? Using this blue line I have marked one, and using this blue line I have marked one. So between these two subarrays, this yellow part is common, which means now I need to compare this. I need to keep them together as close as possible. So let's say that is y. Then this will be again either y plus 1 or y minus 1. Now for x I have chosen x plus 1. Which one can I choose for y? Can I choose y plus 1? Can I choose y minus 1? Can I choose both? This is important. If you look at this guy, from a of 0 to 3, that is this pink line. And if I look at this last blue thing, this is a of 2 to 5, from 2 to 5. Can I say between these two also the difference has to be less than equal to 1? So from minus 1 to 1. Right. So if from here, if you see, from here if it is increasing by 1, from here also it is increasing by 1, then can I say in this second subarray, two elements are greater than the previous subarray. Two elements are greater than corresponding elements of previous subarray, which means the difference is 2 now. If I choose y plus 1 over here, can I say that x plus 1 and y plus 1 both are basically 1 greater than these two elements? So the overall difference is 2, and that is not allowed. And this tells me that, hey, if I've chosen x plus 1 over here, I cannot choose y plus 1 over here. But if I choose y minus 1 over here, then I'm fine. So what am I basically saying? That, okay, if you forget all these, what I'm basically saying is, according to this guy and this guy, for the first and the second subarray, I know that the difference of these two has to be up to 1. And they can be, and this second guy can be either x minus 1 or x plus 1. Now I know that, okay, this one and this one again has to have comparable sum. The difference cannot be greater than 1. So what do I see? One element has become x plus 1, I've taken that, I've considered that without loss of generality. The other element, I can say if this is x plus 1, I can say, hey, this element cannot become, or this cannot become y plus 1. You have to keep this as y minus 1. You have to keep this as y minus 1 so that the net sum, the net difference between these two sums is 0. It cannot be 2, it cannot be minus 2, so you have to keep them different. If here you are choosing plus 1, then here you have to choose minus 1 from with reference to this guy. So there I've done plus 1, that means the next one I'll do minus 1. That's it. So which means if I look at, if I take one example, let's say 10 4. Let's see how we can form 10 4. 1 2 3 4 5 6 7 8 9 10. Any indices, k equal to 4. Okay. So this is the first subarray, this is the second subarray, and so on. First subarray, I can literally keep anything. So let me start with 1. So over here I can say, hey, increase yourself by 1. So this is 2. Now the same rule applies going forward. I can say, okay, you are the first element over here. If I consider your next subarray, this element also has to behave similarly. So I will keep 3 over here. So at distances of 4, can I say these are connected? This one and this one, they are connected, right? Now let me see. Can I say in the same way, this guy and this guy are connected? Why? Because this one and this one differ only by these two elements. So their difference cannot be more than 1. So definitely I can say using the same logic that these two are connected. And using the same logic I can say these two are connected. Okay. And now the difference will have to go like minus 1. So I have many different strategies for this. I can start 10 over here. Or I can say, hey, start from the right. You have completed up to 3 now. 3 is the last one. So start from 4, start from the right. You can say 4 over here, then 5 over here, then 6 over here. So these blues are connected, so I'm going like 4, 5, 6. Next I can say, hey, the next one is connected to this guy. Distance of 4 means again the same thing. This one and this one differs by the difference of those two elements at the two extreme ends. So yeah, once again, now this time you can guess it well. I have done a plus 1 over here. I have done a minus 1 over here. What should I do for the next one? For consecutive ones, I know that factor will come in. So keeping this factor in mind, that this particular thing and this particular thing, sorry, this particular subarray, this particular subarray, yeah. So between the yellow subarray and the orange subarray, I can say that the first two elements and the last two elements will make the difference. So if this is minus 1, the next one has to be plus 1 to meet it. So that's exactly what I'll be doing. I'll say, hey, the difference here, it will basically increase by 1. And the same over here, if there would have been a gap, there is no gap, so no need to worry. So this is, you can choose anything. Okay, you have completed up to 6, so you can start from 7 and then 8 over here. And then the similar way, you can say that this and this one is connected. So 9, 10, and this one, this time in the minus 1 form. So 9 first and then 10. That's it. Now if you see any 4, what trend are we following? We are basically following this trend, that first here we are going plus 1, then we are going minus 1, then we are going plus 1, then we are going minus 1. Yeah, this is the next element. And over here once again, I mean, this trend is going to follow. So due to this plus 1, minus 1, if you take any two subarrays, you can actually compute and see that the plus 1, minus 1 are sort of together. So the net sum will either be plus 1 or it will be 0. In which cases plus 1 depending on the difference between the positions of the first elements of the two subarrays. So if you look at this one and maybe this one, so if you look at these two elements, 10 is common, and for the remaining elements you can see there is 1 plus 1, 1 minus 1, 1 plus 1. So there is a net plus 1. So can you observe this, that you have 1 plus 1, 1 minus 1, and 1 plus 1 between those two subarrays, between these two subarrays that I have marked in yellow. So that's it. Always if it is plus 1 minus 1 plus 1 minus 1, the sum starting from plus 1 up to any place is going to be either plus 1 or it will be 0. So that's it. One important thing over here is that I'm doing it at intervals of 4 or intervals of k. What if k is odd? What if k is odd? 1, 2, 3, 4, 5, 6, something like this. What if k is 3? Then I'll say something like this, that hey, from here to here, from here to here, something like this. Again, from here to here, from here to here if there is anything else. Again, from here to here, and so on. As a result of this, over here I'm applying plus 1. Let's say over here I'm applying minus 1. For the yellow I'm applying plus 1. Now, for this yellow I'm applying plus 1 to here. And for the purple also I'll end up applying plus 1 to here. There is a problem, there is a confusion that gets created. If k is odd, you can see that in this window of k, the first window of k, the last element I am assigning that I'll increase you by 1 as I move forward by k. The next window is starting at the next element, and over there also I'm applying plus 1. If k is odd, this particular problem is going to arise. And that's why, to simplify the situation for us, it is given that k is even. It is given that k is even. So that's it. This is basically, so sometimes solving these problems are easier because you just see pairwise and you complete it. But these are the edge cases for which you need to be focused. Often without understanding the edge cases, you can solve the problem. Like over here, it's given that k is even. If you overlooked it, if you didn't know, you could have solved this problem. But yeah, that's the reason why for odd k, this particular approach will face hardships, will face difficulties. Question arises on whether it will be possible or not. Very different problem altogether. So that's it. Let's see what's the time complexity. Let's look at the coding implementation and let's infer that. Yeah. Okay. Very simple code, small code. What I've done is inputs. Then I'm just checking, hey, if you are at the, I'm basically exploring all the starting indices. First window from 0 to k minus 1. And then plus k I'm basically going for each I. For each I I'm basically going, I'm adding by k and going to all those locations. So I'm saying, hey, if you are at 0 or 2 or 4, basically if you are at even index at the beginning, choose plus 1. You're in the plus 1 category. So as you move ahead, keep on placing x, which is going to increase by 1. X I've started from 1. And if you are at odd position, then fill from the rightmost point. So I'm going to the rightmost point. L is basically the rightmost point now. And I'm starting from there and coming back up to 0. So I'm gradually decreasing by k. If you look at this, so I'm gradually decreasing by k and coming over here. L equals to x, x plus plus. Yeah. At the end, I'm printing everything. So what am I doing? For the starting positions or indices that are even, I am going left to right, increasing 1. And for the other positions which start from odd position, I'm going to the last position that is tied to it in the plus k manner, and I'm going back from there. So I'm going back, increasing by plus 1. It's basically going minus 1 from the left is the same as going plus 1 from the right. So yeah, that's it. Small solution. What is the time complexity? It's just linear. I'm going from left to right, right to left. That's it. It's linear. And if I consider for it's a slightly more intrigued one than simple linear. For k different elements, for k different starting positions, we are considering it. So the calculation of time complexity will be something like this: that for k different starting positions, for each starting position, I have to go maximum how many? I am taking k jumps, so it will be approximately n by k. N by k plus 1, n by k minus 1, something like that will happen. Doesn't matter, approximately n by k, which means k into n by k gives me big O n. That's how it is linear. I hope you found this video interesting. I hope it was informative. You get a lot of questions of this kind, and the only way to develop proficiency in this kind of problems is through practice. There are no classical problems, etc., to make you a pro in this kind of problems. So see how it is getting solved. Consult with other programmers if you find that interesting. See how they are solving it. Let me know if you have some other approach of solving it. But this is, you can say, a stereotypical kind of a thing of noticing what's of interest, what are connected, what are not connected, and solving them. So yeah, let me know if this was interesting. Do share with folks who might find this interesting. And see you all in the next videos. Take care, keep coding.